So we have questions related to the Newton's law of motion. Same idea. For example, if we say this truck was moving at a certain speed and suddenly applies the brake. So when the truck applies the brake, what will the direction of the friction for the box in that case? Right or left? The truck is moving and it applies the brakes and it is decelerating. Slow down. What will the direction of the friction? What should be the direction of the friction? Right or left? The direction of friction always opposes the motion. Look, when the truck was accelerating forward, what is the tendency of the box? The tendency of the box is to slide down, like move back. So friction opposed, so friction was forward. But now what happened? The truck is decelerating, means it slowed down. So if the truck is decelerating, now what is the tendency of the box? The box tend to move forward. So if the box tend to move forward, what will happen? The direction of the friction will be opposite. And if the friction force is not sufficient to stop the box, then this box will hit the truck. So that's why the direction of the friction changes with reference to the motion. If we accelerate, in this case, the friction is forward. But if we decelerate, the friction will be backwards. Now, the part B of the questions, once the lorry has reached its destination, the back of the lorry is tilted at an angle of theta. Three forces act on the box. The one is the weight, another one is a normal contact force, and the third one is a friction. As you can see here, what is the tendency of the box when it is on inclined surface? Tendency is to slide down. So that's why the friction opposes the motion. So the direction of the friction is opposite. To resist the change, that resists the motion. State the expression for the components of the weight parallel and the perpendicular to the back of the. So we'll resolve this weight into the components. So we resolve the weight into the component. Weight will have two components. One is with an angle. Another one is against the angle. And the theta here will be same. So the one which is with an angle, that is W cosine theta. And the one opposite to the angle will be W sine theta. So state the expression for the component of the weight of the box parallel to the back. So which is parallel to the back? So W sine theta is parallel to the back of the. So this will be W sine theta is parallel. This is a W sine theta and this is the back of the lorry. They are parallel to each other. And which is perpendicular 90 degree to the back of the lorry. So as the weight was acting downward, this weight will have the two components. One is parallel, another one is perpendicular. So this is W cosine theta and this one is W sine theta. So W sine theta is parallel to the back of the lorry and W cosine theta is perpendicular to the back of the lorry. So in the question, they only ask which of the component of the weight parallel to the back of the lorry and perpendicular. So we just have to resolve the weight into the component. So here weight is acting. So we took an axis here. This will be W cosine theta and opposite will be W sine theta. So W cosine theta is the component of the weight which is perpendicular to the back of the lorry. And W sine theta is a component of the weight which is parallel to the back of the lorry. So this will be W sine theta and this will be W cosine theta. Is it clear now, this one? remember we did the last session, the inclined surface. So whenever we have the inclined surface, the angle theta is here. So weight is acting downward. So if we take an axis, the theta, these two will always be same. So we always resolve the weight into the components and we work out the perpendicular and the parallel components. Now the angle is increased until the box is just about to slide. The F is 0.32 R. Calculate the value of a theta at which the box is just about to slide. So the value of the F is given. So we have the two components of the weight. One is W cosine theta, another one is W sine theta. So this is W cosine theta and this one is W sine theta. It is about to slide. So when they say it is about to slide, what I can consider a resultant force? It's not sliding or moving. So what I can say about the resultant force? I can say the resultant force is 0. Because it is just about to slide. Means till now it is stationary. So the resultant force should be 0. So if the resultant force is 0, R is acting upward and W cosine theta is acting downward. So I can say R minus W cosine theta is equals to 0. Or I can also say R is equals to W cosine theta. That's one equation. What about the second equation? F is opposing the motion and W sine theta is causing a downward acceleration, try to cause a downward acceleration. So it means I can also say F minus W sine theta is equals to 0 because it is still, it's about to slide. Or I can say F is equals to W sine theta. Now we have two equations. And in the question, they mentioned F is 0.32 R. So I can substitute here 0.32 R is equals to W sine theta. Now I have two equations. I want the value for theta. So what I can do, if I divide the two equations, I can say that 0.32 R is equals to W sine theta divided by R over W cosine theta. Because I divided equation 2 with equation 1. So on the left hand side, it was 0.32 R, and on the right hand side, it was W sine theta. And on the left hand side, it is R, and the right hand side, W cosine theta. So when I divide them, we can simplify. R will cancel with R, W will cancel with W. What is sine theta over cosine theta? What we call a trigonometric ratio. Sine theta over cosine. Sine theta divided by cosine theta is known as, yes, good, Ahmad, that's tan theta, tangent theta. So tangent theta is 0.32. I need the theta. So I will move tan other side. So it will be tan inverse 0.32. So what's the answer? At what angle it's just about to slide down? 17.7. So 17.7 degrees. So when the angle is 17.7, it is stationary. But if I increase the angle more than 17.7, the box will slide down. Is it clear? This one? Any doubt in this question? Do I need to know that? Fine. Some, not too many trigonometric ratios. Just you should know like sine over cosine is a tangent, and 2 sine theta cosine theta is equals to sine 2 theta. These are some you should know, the basics one. This question we have already discussed in the class about the pair forces, similarities and difference. In this question, a student is asked to provide an explanation why a bottle on a table remains stationary. So complete a free body force diagram. What are the forces I will draw? First, there will be a downward force from the bottle, and then there will be an upward force from the table. What is a mistake in my diagram? I did a mistake in my diagram. Can you identify that mistake? What is a mistake in my diagram? Yeah, two mistakes are there. One is the length. Another one, they should be in the same line. So when I show them, if there's a downward force on the table and the upward force, so I should draw them in the same line. I cannot draw like this. That is wrong. The Newton pair forces always act in the same line and they are equal in magnitude. So I should draw the same line as well. This is the downward force because of the weight and this is a normal contact force, R. In part B, the student writes the following incorrect explanation. What student wrote? The force of a gravity pulled the bottle down. The bottle pushed down on the table. So by the Newton first law, the table pushes up with an equal opposite force. According to Newton third law, if the forces are balanced, nothing can move. A student explanation contain errors. Rewrite the student explanation. Can you identify the errors in the statements? Yes. Gravity does not. So force of gravity or weight, you can also use the term weight. That is one thing. The bottle pushes down on the table. So according to Newton, first law, yeah, one of the student identified this should not be Newton's first law. This should be Newton's third law. And according, yeah, the force of a gravity or weight, it is correct. I said either of you can use a gravity or you can use the term weight. Both are correct things. And according to Newton's third law, this is also a mistake. This should be Newton's first law. And if the forces are balanced, nothing can move. That is also wrong. If the forces are balanced, if the stationary object, it will remain at rest. If it's a moving object, it will move at a constant speed. So what should be the right statement? The force of the gravity or the weight pulls the bottle downward. The bottle pushed the down on the table. By Newton's third law, the table push up with equal and opposite force. According to Newton's first law, if the forces are balanced, the object should either be at rest or if it's a moving object, it should continue to move at a constant speed. So nothing can move is not explaining all the cases. Nothing can move. Yeah, we can say object remain in equilibrium or balance. That you can also say. Is it clear, this one? The third line in the table push. To force because the bottle is on the table, so there's a downward force from the bottle on the table. So the table will push the bottle up. Try to, according to Newton force. This is a right statement. So actual mistakes which you have to point it out is the Newton first law, Newton third law, and nothing can move has to be changed. So these are some questions from the Newton's law. We'll start the topic which is related to momentum.